Hi, kids. All right. Hey, find this page in your packet. Let's just go through this because I want to make sure this makes sense. Because if you understand this picture, okay, you will do ray diagrams correctly because this is all about ray diagrams. So we're talking about concave mirrors, okay? Concave mirrors cave in. This light has to follow the law of reflection. If I was to draw my normal line, it would look something like this, okay, perpendicular to the surface. But do you see how this angle and this angle are the same? So they have to bounce like this. But the light rays that come in parallel, they're going to bounce down, but they don't randomly bounce down. They go through the focal point. That's the whole point of the focal point. Okay? So if you understand this picture, it's going to make a lot of sense. That's called converging light, bringing it together. This means that it is a real focal point. The light is really going there. Okay? Which means when you're using the optics equation, which we're going to work through, that means the value for f has to be positive because that's real, okay? All right, so remember this picture, okay? Then let's find this problem, and we're going to work through it together, okay? So, hey, I want to draw my ray diagram. Well, guess what? Remember this picture? We're going to draw these light rays first. So, hey, I'm going to have a light ray that comes in parallel. So let's draw it coming in parallel. By the way, this is my random object. It's really just whatever we're looking at. So maybe we're looking at yourself in a concave mirror. So then the object would be you. But it's just whatever you're looking at. Everybody can draw an arrow, so that's why we're going to use an object for the arrow, because not everybody minored in art like me. Okay, so let's draw your light ray coming in parallel, and we're going to draw it all the way to the mirror here. So there's that light ray coming in. And then where is it going to go? Oh yeah, it's going to go through the focal point. So we're going to draw it through the focal point. Now, let's just make sure we're drawing it correctly. Do you see how this would be over 1, 2, 3, 4, 5 dots, and then down 4 dots, okay? So then I want to go over 1, 2, 3, 4, 5, 1, 2, 3, 4. I know it has to go through that point. So we're going to use the graph paper to make sure that we draw this correctly, so that it would look something like that. Okay, there's my first light ray. And that should make sense. It's parallel through the focal point. Well, now our next light ray is just going to do the opposite of that. Well, if it goes parallel and through the focal point, then if I go through the focal point, guess what it's going to do? Oh yeah, it's going to come up parallel. So let's do that. We'll draw through the focal point. And then it's going to come up parallel. Okay, so I have 2 light rays drawn. So parallel focal point, parallel. Now you can already see right here, that's where those light rays are going to meet. So that this point is actually going to be this point. So right away, my image is going to be upside down. So right away, I can already tell it's going to be inverted. Right away, you can see how small my image is going to be. So it's going to be smaller, okay? And you can see the light rays are really going there. It's going to be a real image, okay? But just to check and make sure that we're doing this correctly, I want to show you how we can draw the other light rays as well. The whole point of the center, okay, remember the center, if it goes this way through the center, it would just bounce straight back. So the center ray, if we want to draw that one, it would look like this, where it's going to go object through the center and then go just go straight. Whoops. Okay. And then if you want to draw the last ray, which is also kind of sometimes it's called the center ray too, because it's hitting the center right here. Well, this light ray, if it hits this one, okay, well, it has to then bounce off and go through 1, 2, 3, 4, 1, 2, 3, 4. It has to go through this point. because it would have to follow the law of reflection. So it would look something like this, and you could see all of those light rays would go through that point here. In fact, you could pick any other light ray. Like, I could have a light ray hitting right here on my mirror, and guess where it has to go? Oh yeah, right there. You could have a light ray hitting here, and it's got to go there, because all of the light coming from this is coming together there. So then the whole point is to draw in your image. So let's draw it in. So then I have my real image is right there. Okay? So now let me show you how we can use the mirror equation. So let me write it down. Here's our optic equation. Okay? So if you look, SO is here. That's how far away from my mirror I am. So I think I'm 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So my focal is 6 units, whatever this is. So there's 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I would say 1 over 22 plus 1 over SI, because we're going to check to see if my SI is correct, equals 1 over F, and we said F was 6. So, hey, I'm going to tell you, don't even try to do fractions. Just use a calculator and plug it in. Okay? So 1/6 minus 1/22, and then take the inverse of that, and you get 8.25. So my SI equals 8.25 units, whatever, I don't know what those units are, but whatever those units are. And if you look, this was 6, 7, 8. I would buy that would be 8.25 units away. Okay. For the magnification, we're going to set it up like this. So remember, this equals SI over SO, absolute value, or this equals HI over HO. Okay, so again, if we wanted to solve for, let's do magnification first. So we'll go SI over this. So 8.25 divided by 22 equals 0.375. So the magnification is 0.375. So it's going to be 0.375 times smaller. And if I start with 4 and I multiply by that, because the height was this, times 4, I get 1.5. And yes, I would say that is about 1.5. So my HI is 1.5 centimeters. But this is the process that I want you to go through for these. When you are drawing a ray diagram, you only have to draw 3. Okay, 2 to locate where the image is, and then the third one is just to verify it. But you should know how to draw all 4 that I drew. You're gonna, use your lens equation, magnification, and do that, and then you should be able to do that. All right, I'm gonna come back and do the virtual one. I'm not gonna do the whole process of the virtual one, but just so you can see how to solve it. And otherwise, you'll be good. All right, see you soon, kids. Bye.